Hi guys, we're going to look at this topic called matrices. So now we're going to look at both paper 1 type of questions and paper 2 type of questions. But before we can start solving, I would love to introduce you to what is required of you to know from the syllabus. Okay, both GCE and internal examinations, you're using the same syllabus. So when you're doing this topic matrices, there are a few things that you have to be familiar with. So one of the things that you need to be familiar with is how you can find the transpose of a matrix. So the first thing, know how to find the transpose of a matrix. So it's very much important. So how to transpose a matrix. So this isn't supposed to be there. Let me just do that. So how to transpose a matrix. Then the second thing that you should know is you know how to multiply matrices. So how can you multiply matrices? Then the third thing you should find is you know how to find the inverse of a matrix. So these are the subtopics that we're going to look at under this topic of matrices. So transpose, how to multiply, and how to find the inverse of a matrix. So to start with, I'm going to put an example that will start with finding the transpose and the multiplication part. Then that's when we'll be able to proceed with the other things. Now suppose here is a question, just here I'm going to say example. So in this example, suppose we have two matrices. So I'll say we have matrix M. So matrix M is given by we have 1, 5, 2, 7. Right, then we also have matrix N. So matrix N, so I'll say we have matrix N. Matrix N has been given to us to be 0, 1, then 2, 0. So like that. So that is matrix N. So now suppose now I want to find, so the first one, so we say we find the transpose. Now this is the notation. So if we say m to the power t, we're simply saying the transpose of matrix M. Then the second one, you find n m. So you're simply saying the matrix N multiplied by the matrix M. So how do you go about this? So now to do this, so this is what you're going to do basically. So start with the first one, which is to transpose a matrix. So to transpose a matrix, it's easier. So a matrix has got what we call rows and columns. So if you are to transpose a matrix just there, you change the rows to become columns and the columns to become rows. So look at what will happen here. So check, this is a row. This is a row 1, 5. This is a row. It becomes a column, a 1 there and a 5 there. Then this is another row. It becomes a column 2, 7. So the process in which you change the rows to become columns, in the same way the columns are becoming rows, we call it transposing of a matrix. So that is how you can transpose a matrix. So basically, to transpose a matrix is to change the rows of that matrix to become columns. Then the columns, they are becoming rows. Right, so that's the simplest of matrices. Then what of matrix multiplication? Now to multiply a matrix, so we're given two matrices here. So we have matrix n, so I'm going to say we have n. What is n? N is 0, 1, then 2, 0, like that. Then this is being multiplied with matrix m, and matrix m is 1, 5. You get the original matrices, not the ones which have been transposed. 2, 7. So these are the two matrices. So now these two matrices, we are supposed to multiply them. So here, how are we going to do that? So we proceed. To multiply a matrix, you say the row of, so it's row by column. So to multiply a matrix, we say row by column. So this is what we're going to do. We're going to say the first row multiplied with the first column. So the first row of the first matrix with the first column of the second matrix. So check out, this one is our first, this is our first row, and this is our first column for the second matrix. So I'll say this 0 multiplied by 1, I'll get 0, then we say plus. This 1 multiplied by 2, I'll say 2. Then I'll say this same row multiplied now by this other column. So I'll say 0 multiplied by 5, I'll get a 0 plus, then 1 multiplied by 7, I'll get a 7. Then I'll close like that. Then I'll come to the row which is down here. It's going to multiply the column there. So 2 multiplied by 1, that is 2, plus 0 multiplied by 2, that is a 0. Then we get this same row with the other column. 2 times 5, that is 10. Then we say plus, we say 0 times 7. So we get a 0 like that. Then we simplify. We're now going to say what is 0 plus 2, that is a 2. 0 plus 7, that is a 7. 2 plus 0, that is a 2. Then 10 plus 0, that is a 10, like that. So that is how we can multiply two matrices. So the rows of the first matrix, so we're getting the row multiplied by the column. So that's basically how you can go about matrix multiplication. Right. Now that we have looked at how we can multiply matrices, we're now going to proceed in how we can find the inverse of a matrix. So in finding the inverse of a matrix, we're going to proceed by first determining how to find the determinant of a matrix. Right? So to find the inverse of a matrix, I'm saying, so you first need to know how to find what we call the determinant. So you cannot find the inverse of a matrix minus finding the determinant. So you first have to find the determinant, and then you proceed in the following manner. Now suppose on this one, we're trying to find the inverse. Now using determinant, you first need to know how to find the determinant of a matrix. So now look at this question. So suppose that we have a matrix. So suppose we're given a matrix. So that matrix is, so we call it matrix A. Then that matrix has been given to be, so we say 1, 5, then 2, 7. Then we now say find determinant. Now this is what we use, so when to mean determinant, so find the determinant of A. So we use the modulus to mean determinant. How can you find determinant? Determinant has got a formula that we use to find. So we say determinant, we do that. Determinant is given by AD minus BC, where for a normal matrix, so you say this is our A, this is our B, that's our C, that's our D. So we say what is A times D? So our A is 1, our D is 7, so 1 times 7, that is a 7, minus BC. What is B times C? So 5 times 2, that is a 10. So 7 minus 10, we get negative 3. So therefore, negative 3 is the determinant of that matrix. Now that we know how to find determinant of a matrix, I'm going to put up a question that we're going to do as our last example that will also help us in finding both the determinant and the inverse. So since the inverse is the last thing, so let's say another question here. So suppose we have a matrix. So given matrix, so we're going to say the name of this matrix is matrix B. So given matrix B to be as follows: 2b minus 1, then this side we have a 4 here, then we have negative 3b, and this side we have negative 5. Alright, then so this is what we have. Then now we are saying if now the determinant, so if the determinant of this matrix is equal to 15, so they're telling us to say the determinant is equal to 15, then now the question now is saying find the first part, we find value of b, and the second part we find the inverse of the matrix B. So I'm going to denote inverse is denoted like that. So that is how we denote inverse. So how can we go about such a question? So this is what we're going to do. So first and foremost, we have that question. So you're going to agree with me that this part will represent A, this one B, this one C, that one D. So therefore, if they've already given us the determinant, and we know to say the determinant of a matrix is given by AD minus BC, and they've told us to say the determinant is 15. So where there is determinant, I put 15. Then where there is A, it's 2b minus 1. Then where there is D, I'll use brackets because those two are multiplying. I'll put negative 5. Then I'll now say minus, our B is 4. Then the 4 is multiplying by 3, or our C, which is negative 3b. So say 15 is equal to, now the negative 5 is multiplying everything inside the bracket, so it will start by multiplying negative 2b, so that it becomes negative 10b. Then it multiplies negative 5, so that it becomes positive 5. So here again we say negative 4 multiplied by negative 3, so that 3b, so that it becomes positive 12b. From there we can group the like terms together. Here I can say 15 will subtract 5 because the 5 is positive here. This side it will be negative. Then I have negative 10b plus 12b. So 15 minus 5, that is 10. Then negative 10b plus 12b. So different signs you subtract. So it will be 12 minus 10, we get 2, positive 2b. Then from there we're going to divide on both sides. So we divide by 2b, or we divide by 2, I mean, on both sides. So this side we divide by 2, even this side we divide by 2. So 2 into 2, so that b now is equal to 2 into 10 is 5. So the value of b is equal to 5. And you can prove this. So you can put in 5 to be the value of b, then try to find the determinant again if it will give you 15 as a determinant. So that is straightforward. Now that you have found the determinant of now that you have found the value of b, what we're going to do is to find part B. We're going to write matrix B with the value of B now. So we're saying B is 5. So this is 2B minus 1. If I put in 5 here, it will be 2 times 5, which is 10. 10 minus 1, that is a 9 here. Then there the 4 will remain 4, and negative 5 will remain negative 5. Then here it will be negative 3B. Negative 3 times 5, we get negative 15. So therefore, now that we have that one, we need to find the inverse. So to find the inverse, so this is how we find inverse. Inverse of B is equal to 1 over the determinant of B, then open brackets, we say D here, A there, negative B, negative C. Then what we're going to do to say determinant of B will be equal to 1 over, so this is a formula now I've given you on determinant. So this is a formula of inverse, not determinant. So this is a formula we are using on inverse. So to find the inverse of B, we say 1 over determinant. Determinant, they gave us 15. If you check the question, so we say 1 over 15. Then we say that, what is our D? Our D is negative 5. What is our A? Our A is 9. Then what is our negative B? It's positive 4, but if you multiply it with a negative, it becomes negative 4. Then negative C is negative 15. If you multiply it with a negative, it becomes positive 15. So what you can do, you can multiply 1 over 15 throughout because it's a scalar. You can multiply 1 over 15 multiplied by negative 5, 1 over 15 multiplied by negative 4, 1 over 15 multiplied by 15, 1 over 15 multiplied by 9. Or you can just simply leave it here to say this is our inverse. So you can either multiply throughout or you can leave it at that state. That would still mean that is our inverse. So that's basically how you find the inverse of a matrix given determinant. Now if that is okay, I'm going to leave some questions that you can try out just on this topic, matrices. So if I put a task here, then I say the first part of the task, suppose we have, let's say, given, so we have matrix N is equal to that. So this is X, that is 2, then 2X, that is 6. Then we're now saying A, find X. So we're saying find X if the determinant of the matrix N is 8. So if the determinant of the matrix N is 8, then part B, you find, so we say write, it's the same, so write or find the inverse of N. So that is one and the same. Then the second part, second question, so we say given a matrix, so that we can say matrix C. So if you're given matrix C, it is as follows. So 7 here, 1 here, 2 there, then we have a 3 there, we have a 4 there, then 5 here. So we have that. Then from there, we are now saying, so this is question 2A. Then we are now saying find the transpose of C. So find C transpose. Then part B, so express, So suppose you have this matrix, so we have 1, 8 here. So these, that, that, that. So this is a 2 here. This is a 2, just in case you're unable to see. That is a 2. So let me just write it properly. So there is a 2 here. So express that as a single matrix. So you express that as a single matrix. So you try on those. So this here you are multiplying. So you multiply these two to express as a single matrix. So you try on those and see what you are going to get as answer.